Hello friends, welcome to Susan and John MathTube. In this video, we're going to learn a very important topic that is called the reduction formula. But this is very important for the architecture students. Anyway, it's a very beautiful concept. In reduction formula, what we do is we create steps. We learn how to create step. If you ask anyone who is living in the second floor or the third floor, they will tell you the importance of step. Think about it. If you don't have step, won't it be really hard to jump from the third floor to the second floor, or from the second floor to the first floor, or from the fourth floor to the third floor? Yeah. And anyway, I'm not bothered about climbing because I'm teaching you reduction formula, and that is always going downstairs. So once we create this step, we will learn one example, and that means I'm going to teach you how to use the steps so that we reach downstairs in a very comfortable manner. Okay. Now, one more small comment about your syllabus. Look at this. In your syllabus, in integration, you learn properties, and then comes improper integrals, and then comes a very powerful technique, that is differentiation under the integral sign. So the aim of your syllabus is to teach you a lot of new methods so that you become more powerful in integration. And then they want you to learn two more things, that is reduction formula and beta gamma integrals. Now, once you complete these 5 topics, they will teach you application of integration, area, rectification, volume, surface area, etc. etc. And when you learn application, because as an engineering student, you'll be more interested in application. And when you learn application, you'll understand the importance. You'll understand the importance of mainly these 2 topics. But wait a minute. This is not the end of mathematics. In the next semester or in the coming semesters, you will learn Laplace transform. And at that point, you will remember improper integrals. So look at this. If you ask me why you are learning all these topics, the main point is you are enhancing your integration skill so that it can be used in your applications. Anyway, with that, let's start the topic reduction formula. Okay, let's go for a classic example of reduction formula, the evaluation of sine to the power nx dx. Now look at this. I'm sure you have seen this integral starting from the time you learned integration. Most probably, if you look at your class 11 book, you will see a question called evaluate integral sine cube x dx. And later on you might have ended up with integral sine to the power 5x dx, etc. etc. So today we are going to learn a method or a step creating method so that you can evaluate sine to the power any positive integer dx. Okay, so the first thing we do is we will give it a name, and I am going to give the name in so that you can connect this with the power. So I am naming, or I am giving the name intentionally, so that if you want to evaluate sine to the power 4x dx, you will remember I4. Did you get the point? If you want to evaluate sine to the power 10x, then it means we had to find I10. Is that clear? Okay. Now remember, our aim is very simple. We plan to move from a higher point to a lower point. So we are planning to create steps so that we can do that in a comfortable manner. Now look at this. I always watch students moving around the steps. Some students move very slowly. They move like one step at a time, slowly. But at the same time, I have seen some students jumping steps. They will jump from the first to the third and then third to the sixth. So that is exactly what we are going to do. We are going to write IN in terms of IN minus 1. And these are like the normal students who move one step at a time. And now let's look at some hyperactive students. They move like n minus 2. That means they jump 2 steps at a time. And some are like extreme students. They jump 3 steps at a time. Okay, so let's have a very clear meaning later. But first, let's go for the derivation. Okay, now look at this. The method for sine and cosine will be analogous. That means if you know how to find the reduction formula for sine, and that clearly implies you will be able to find the reduction formula for cos. Because sine and cosine are called the co-functions. They are connected by the word co. So remember, sine and cos are basically co-functions. Similarly, tangent and cotangent, and secant and cosecant. So in this video, I'll teach you how to find the reduction formula for sine to the power nx dx. And your assignment will be, your job will be, you try to find the reduction formula for cos to the power nx dx. In the next video, I'll teach you how to find the reduction for tan to the power nx, and you try and find the reduction for cot to the power nx dx. Okay, so the method here is very simple. What we do is we write a power m as a power m minus 1 into 1. Isn't it true? Because a power m into a power n is a power m plus n. So what I did is I am splitting this power into n minus 1 and 1. Now we will apply integration by parts. I hope you still remember integration by parts. What we do is u into integral v minus inside a very big integral differential of u into integral v. But I have a suggestion. Do this integration in your mind. Otherwise, your answer paper will be in a mess. It will be like integral, integral, and again inside an integral. So it's better to do that integration in your mind. Okay. Now, before we start, I have to discuss one more small thing. That is the derivative of sine to the power n minus 1x. Now look at this. Sine to the power n minus 1x is actually sine x the whole power n minus 1. And basically it looks like x to the power n minus 1. So we apply chain rule here. So if you ask me what do you see here, I will give the answer. I can see something to the power n minus 1. I have something to the power n minus 1. And if I differentiate this, I will get n minus 1, the same thing to the power n minus 1 minus 1, and multiplied by, because we have to use chain rule, cos x. I hope you got the point. And we will write this as n minus 1 sine to the power n minus 2x cos x. I am doing this separately because some of the students are weak in chain rule of differentiation. I hope you got the point. And the second question, what is integral sine x dx? Exactly, minus cos x plus c. Now that is more than enough so that we can start with our reduction formula. So look at this. I'm going to apply integral u into v. So what I do is I write the first function as such and integrate the second. That will give me minus cos x. Did you understand what I told you earlier? Don't write integral, integral, integral. Just do the integration in your mind. Minus inside a very big integral, you have to differentiate this. I'll show you that once more. This looks like something to the power n minus 1. So I will write n minus 1, the same thing to the power n minus 2 times the derivative of sine x is cos x. Okay, so that differentiation part is done. And one good thing is the second term inside the integral and the second term outside the integral is the same. That means I'm just going to copy that minus cos x and I'll put dx from that differential. That's it. That's it. Okay. Now we will keep on modifying this till we get something good out of it. Now this minus and minus will be plus, and n minus 1 goes outside, and we have integral sine to the power n minus 2x and cos square x. And cos square x I'm going to write in terms of sine 1 minus sine square x dx. I'm going to skip that step. It's simple enough for you. We get cos square x here. I'm going to put it in terms of sine square x. If you ask me why, I will show you the question. We are trying to find the reduction formula for sine to the power nx. So I want everything to be in terms of sine whenever we have integration. Okay, so the next step, we use distributive property. So I get minus sine to the power n minus 1x cos x plus n minus 1 integral sine to the power n minus 2x minus sine to the power nx dx. Okay, wait a minute, I'll explain that. What is a power m into a power n? Yeah, a power m plus n. So what about a power n minus 2 into a to the power 2? Of course, that will be a power n minus 2 plus 2, that means a power n. So when we distribute this, when we open the bracket, we get sine to the power n minus 2x into sine square x, and we end up with sine to the power nx dx. Okay, now another thing that is very simple. What is integral f minus g? Isn't it integral f minus integral g? Of course. So what we do in the next step is we split this integral. Okay, I'll use my eraser, but as a student you cannot do that. You have to write. So I'll get dx here minus integral dx, and I put the bracket outside, and once more I'll use my eraser. Okay, it's not a big deal. I'm sure you understood this. Okay, now comes the ultimate question. Who is this character? Wait a minute, I have seen that somewhere. Okay, in the beginning I told you, I am giving the name in by associating it with the power n. So look at this. Now we got something similar to that. We got power n minus 2 and power n. Okay. So I'm going to write in equal to, I forgot to write n, minus sine to the power n minus 1x cos x plus n minus 1 into, this is in minus 2. I'm 100% sure about that. I'm 100% sure about that because I made the name in corresponding to the power of sine. Okay, so let's distribute this, and we get in equal to minus sine to the power n minus 1x cos x plus n minus 1 n minus 2 minus n minus 1 in. And now what we do is we solve our aim is to find the value of in. So I take in to the left side and I keep the remaining part here. Now just take in outside, you'll get n common, so we get in. Just take in common, so the remaining you can do minus. Now what we do is we divide throughout by n, and then I'm going to claim that is my reduction formula. Can I claim that is my reduction formula? Of course I can, because look at this. I have written in terms of in minus 2. I told you in the beginning, my aim is to go downstairs. I am in the 3rd floor, I want to reach the 2nd floor. And no, I'm not going to do that. I'm not going to jump. I'm not going to do that directly. So I created a step which will take me down. And here actually I'm jumping 2 steps down. See, that is that n minus 2. Okay, anyway, if you write up to this, you can write this is the required reduction formula. But to be honest, your answer is not complete and you may lose mark. If you want the answer to be perfect, you should write something called the ultimate integral. So, ultimate integral means where will we reach ultimately? So, look at this. This shows you we are jumping 2 steps at a time. Now, let's imagine like what you call, we have total, we are at the 10th step. So when I perform this, I will reach step number 8. Then I will reach step number 6, step number 4, step number 2, and finally 0. So ultimately I will reach I0. Now just imagine I'm standing at step number 7, and if I use this formula, that means if I jump 2 at a time, I will reach step number 5 and then 3 and then 1. That means if you start with an odd number, ultimately you will reach I1, and if you start with an even number, ultimately you will reach I0. And a reduction formula will be complete only if you find the ultimate integrals. Anyway, in your exam, you may get full marks when you complete this, but trust me, the answer is not perfect. The answer is not complete. So, I will strongly recommend you write these steps and make it perfect from your side. So, please write the ultimate integrals. And we will write, if n is even, the ultimate integral is I0. By the way, what is our in? I hope you still remember what is in. Yeah, integral sine to the power nx dx. So what will be I0? Integral sine to the power 0x dx. But any finite number to the power 0 is 1. So we get integral dx. And integral dx is x. So I'm going to write those things here. We will get sine to the power 0x dx, and that will be 1, and that will be x plus c. I hope you understood. If you start with any even number, that means if you are trying to find integral sine to the power 8x dx, you are basically finding I8. I8 will be reduced to I6. And then you will again use the formula and find I6. I6 will move on to 4, and 4 will move on to 2, and 2 will move on to 0. Okay, now write the next line. If n is odd, the ultimate integral is I1, and that is the integral sine to the power 1x dx, and that is nothing but minus cos x plus c. So that's it. Now I'll teach you how to apply the reduction formula. Okay, so I have my reduction formula where in is nothing but integral sine to the power nx dx. Let's put it in trial mode and try to find something really small. sine to the power 5x dx. Let's give it a try. So finding this means I have to find I5, and that means I'm going to plug in the value 5 wherever I mark with blue. I hope you're able to see that. I'm going to plug in the value 5 wherever I have marked with blue. So that gives me minus 1 by 5 sine to the power 5 minus 1, that will be 4 cos x, plus 5 minus 1, 4 by 5 I3 as expected, because we are jumping 2 steps at a time. Now to find I3, what I do is I will plug in the value 3 wherever I see blue, because that will give me I3. Yeah, so this will be reduced to, did you understand what exactly we are doing? We are trying to find the answer step by step. Okay, so how do you find I3? Plug in I3 in the same equation. You plug in I3 in the same equation wherever you see that blue color. But please be careful with brackets. So I'll get minus 1 by 3 sine to the power 3 minus 1 x cos x plus 3 minus 1 by 3 I 3 minus 1 2. Finally, I1. I told you, you start working out with any problem related to reduction formula. At the last, you will get an ultimate integral. And we are already ready with the answer. What is the ultimate answer? Minus cos x. So in the next line, I will get my answer sine to the power 4x cos x plus 4 by 5. I am not opening the bracket, that's your homework. Sine square x cos x plus 2 by 3. What is I1? Minus cos x. And put a plus c somewhere. Finished. I hope you understood this. Okay, I am going to give you a small work. The work is very simple. You know the work. I told you the process to find a reduction formula for sine will be similar to that of the reduction formula for cosine, because they are co-functions. So your homework is very simple. Find a reduction formula for cos to the power nx dx. And I hope you remember the first step. You have to do n minus 1x into cos x dx. That's it. You can comment in the comment section whether you got the answer or not. And you can even try evaluating cos to the power 8x dx. By the way, the ultimate integral for this will be I0. So that's it, my friends. I'm going to wind up the video right now. I'll be back soon with integration of tan to the power nx. And as always, if you like the video, please subscribe and share with your friends. So we will meet soon. So till then, my friends, bye.